Sorry about the delay. And can everybody hear me and see me okay? Yeah? Okay. And would request you guys to be a little louder for me at times because my ears don't work well. Getting old. Okay. Okay? Alright. So let's try to recall what we want to do today. Do you guys?
Now we good?
Of course. Take a chair, sit down. So, do you guys remember what we wanted to start today? So we started with trigonometry yesterday, right? We just touched the tip of the iceberg where we talked about how is the right angle triangle so very important for us when it comes to deriving a new topic, a new subject altogether. Yeah? So let's start with that. And yeah. So as we started, that this triangle that you see, it doesn't look very complicated, but this is the mother of a subject called trigonometry. Yeah? That's the basic discussion or the minimal discussion we had yesterday. Does everybody remember that? Yeah? Okay. Hey Davik, you're remote today? Alright. So here, when you look at this triangle, this is called right angle triangle. And why? Because one of the angle is 90 degree or a right angle. That's why this is right angle triangle. And all of you would be knowing yeah, Sukatova, which tells you how to find if you have this angle as theta and this is, let's say, this is the opposite side and this is the adjacent side. So I'll call this opposite side, I'll call this adjacent side. And this is the hypotenuse. Okay? So you guys already know this, right? I'm not telling you guys anything new. Right? So this Sukatova says sine of a theta is opposite side divided by hypotenuse. So this, if I call this as A, this as B and this as C, like we saw yesterday in the Pythagorean theorem, sine of this theta is the opposite side divided by hypotenuse. So it will be A divided by C. Cos of a theta is adjacent side divided by hypotenuse. Cos of theta is adjacent side. This one I'm saying is B by hypotenuse, that is C. And T stands for tan theta or tangent of the theta. Tan theta is opposite side divided by adjacent side. So it will be A by B. This part you guys all will be knowing, correct? Everybody remembers this. But what I said is, so this is the basic of trigonometry, which is called trigonometric ratio or something, right? I mean that's what you would be knowing it by, right? Now we are trying to find out, if I say okay, sine of theta, this theta could be 1 degree, it could be 90 degree, it could be 200 degree, whatever it is. So there are different values of theta for which I was showing you guys a table and I was trying to say that these are the values. Sine theta 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Sine, cos, 10. And I was filling this table by saying that this is 0, 1 by 2, 1 by root 2, root 3 by 2 and this is 1. 1, root 3 by 2, 1 by root 2, 1 by 2 and 0. And this is sine by 10. So I'm not going to fill this table one more time. What we're going to do today is find out why sine of 0 degree is 0. That you see in the table, right? Why sine of 0 degree is 0. Does anybody know what I'm talking about or anything that you have seen in the past? Saranya, Dhanvin, Ritika, anybody? Dev? Arush, Pranit, anybody here? How? Oh, you were in my class before. Okay. So Ria, any idea why I'm saying that sine of 0 degree will be 0? Yes, David.
I picked that by accident.
Okay. Now go back to this table. Okay. Sine of theta, any theta, be it 0, be it 90, be it 150, I don't care right now. I'm saying sine of theta is opposite side divided by hypotenuse. Yeah? I'm trying to find out, here in place of theta I'm saying 0 degree, meaning this value of this theta is 0. Yeah? When my sine of theta is 0 degree, what is going to happen? This hypotenuse will keep moving closer and closer and literally fall on this line, correct? That's when this is 0. So this hypotenuse is moving towards this side, and when it's 0, it literally falls on this. It becomes one line, correct? When it falls on this line, this height of, see, when this theta is decreasing, the height is also decreasing. See, when theta is decreasing, the height has become less. Theta is further decreasing, height has become even less. When theta is 0, this is literally on this side. This is falling on this line. So this height is actually 0. Yeah? Now fitting in the same formula, sine theta equal to opposite side divided by hypotenuse. Opposite side is the side opposite to this angle, which is actually 0. So 0 divided by hypotenuse. What will be the length of the hypotenuse? You are dividing 0 by the hypotenuse. 0 by anything is? Is it making sense? Saranya, Ritika, anybody? Vishal? Tansi, is it sounding okay, beta?
Yes.
Okay. So you can also move little to this side so that you can see what I'm doing. And you can tell me if it is making sense. Okay. So this, what I'm saying is, when this is my sine cos tan ratio, trigonometric ratios, which says sine theta is opposite side divided by hypotenuse. So when you made the theta as 0, you literally made the hypotenuse fall on this line. So eventually this height is 0. So the 0 divided by hypotenuse will give you 0 only. So first column of this table, sine 0 equal to 0, it is looking to be believable. Yeah? Everybody? Dave? Neil, Sarah, everybody, right? Okay. Now, so one table is filled. That is good news. The one column of the table is filled. Now let's look at another situation. I'm saying sine 30 degree, or let's look at another scenario first. Let's go to sine 45 degree. I'm making a right angle triangle such that it's an isosceles triangle also, meaning this side is equal to this side. So I made a right angle triangle, meaning this angle is 90 degree, and I made this side equal to this side. So can somebody tell me what will be the value of this angle and this angle? 45 each. Sum of all the three angles is 180. And I said these two sides are same. If these two sides are same, then the angles are also the same. It's an isosceles triangle. So this is 90. These two together is 90. So this is 45 and this is also 45. Yeah? Is that believable so far? Tansi? Okay. And Tansi, where is Alekhya? She's been missing for a few classes.
Yeah, I don't know.
Okay. Alright, you can check it offline and let me know. Anyways, so now this is a right angle triangle. This side are same, and this is my hypotenuse. Let's say this side's length is A. So that means this is also A. What will be the length of this side? As per the Pythagorean theorem says, if it's a right angle triangle, square of this side plus square of this side will be square of this side. Let's say this is x. So a square plus a square will be x square. X square equal to 2a square, that means x square equal to a square plus a square 2a square, or x will be equal to square root of 2a square, that means square root 2 times a. Yeah. Is this value length of this hypotenuse fine? If this is a, this is also a in this triangle. So then x square will be a square plus a square 2a square. That means x will be equal to square root of 2a square. That means square root of a square will give you a and square root of 2 remains square root of 2. Yeah? Yeah? Okay? Believable so far? Okay. Somebody is missing. I know Niska was supposed to be in the class, but okay, that's fine. So Praneeth, maybe you can close the door so that the AC is a little effective for all of us. The one on the above one. Okay. So we found that length of x is square root 2 times a. Now let's say I am saying this is theta, okay? So if I take this theta, sine 45 degree, I am considering this as an angle. Sine of this angle will be equal to sine of this angle 45 degree will be equal to side opposite to that divided by hypotenuse. Side opposite to that is a divided by hypotenuse. Hypotenuse is square root 2 times a. A and a you can do tic-tac-toe, that means it is 1 by root 2. This is exactly what I have put here. Yeah? Make sense? So just a summary, right? This is a right angle triangle, which is also isosceles triangle. So this angle at this side and this side are same. This angle and this angle will be 45 degree. So we apply the Pythagorean theorem, which says if this is a, then this will be square of this plus square of this will be equal to square of this, and hence we got the value of x, length of the hypotenuse, as square root 2 times the side, and we applied that trigonometric ratio to get the value of sine theta or sine 45 degree. This one is okay. Now take the same angle and say what is cos 45 degree. Cos 45 degree will be equal to same thing. This is the angle. So adjacent side divided by hypotenuse. Adjacent side is also a. Hypotenuse is square root 2 times a. That becomes 1 by root 2. This is also done. Is it making sense to everybody? Riya, Dhanvin, Ritika? Yeah? No. Alright. Vishal, clear beta? Okay. Now, so we saw sine of 0 degree equal to 0. Sine of 45 degree is 1 by root 2. Cos of 45 is 1 by root 2. Now, from this one, sine theta by cos theta. If I do sine theta by cos theta, that is nothing but a by c divided by b by c. That, and here I have tan theta, here is a by b. So sin theta by cos theta equals a by c, and this one flips, so it goes up, c by b. So c and c you can knock off, it's a by b. So sin theta by cos theta is also equal to tan theta, that you already know. Yeah. Here, when you got sin theta equal to 1 by root 2, cos theta equal to 1 by root 2, sin theta by cos theta will be equal to tan theta. So 1 by root 2 by 1 by root 2 gives you 1. So tan 45 is 1. We have filled these, the ones that I have circled right now, and also this one. Now look at the same triangle. Cos 0. What is the value of cos 0? Cos 0 will be a situation when this hypotenuse literally falls on this one. So this was your right angle triangle, this was your theta, and theta is reducing. See, this hypotenuse has come here. Now theta is further reducing, it has come here. Further reducing, comes here. Further reducing to become 0. Literally your hypotenuse has fallen on this line, and whatever was looking like a triangle before is looking like a straight line now. With a microscopic view, with some assumption, we are saying, okay, this is still a right angle triangle, just that my angle is 0. So eventually your hypotenuse and your this side are basically same length now. Because when it fell on this, when the angle reduced, it literally fell on this. So now your hypotenuse, which was this right hand, and your adjacent side, which was your left hand, both are same length. So cos of 0 degree will be equal to the adjacent side, let's say this is A, divide, and this hypotenuse is also becoming A because it's literally falling on this. They are not two different lines. A by A, which will give you a 1. That is what you see here. Yeah? Okay. Tisha is home? Okay. You can take out your shoes. Okay. So you found that cos of 0 is 1. Everybody clear so far, right? So if you have sine of theta is 0, sine 0 is 0, cos of 0 is 1, then will be sine by cos, 0 by 1. Believable? So we have filled 2 columns of this table. Let me turn off the light so that it doesn't keep reflecting on the screen for you guys. Yep. Can you guys see the board okay? Okay. So we filled half of this table, okay? And we have verified whatever we know. With that information, we are able to get that sine 0 is 0, cos 0 is 1, tan 0 is 0, sine 45 is 1 by root 2, cos 45 is 1 by root 2, and tan 45 is 1, which is sine by cos. Now, let's go to 30 and 60. What I will do is, let's look at this triangle. This is a right angle triangle, this is an equilateral triangle. Meaning this side and this side are same length. Okay? Now what I will do is, I'll drop a perpendicular from this point. I have dropped a perpendicular, that means this angle is 90 degree and this angle is 90 degree. Let me give these triangles some name. So my parent triangle was ABC. When I draw the perpendicular from here to here, let's say it meets at point D. By doing this gymnastic, I have split this equilateral triangle into 2 right angle triangles. Agreed? Tansi, Danvin, Riya, everybody, right? Saranya? Okay. Okay. Now, so let's say this side was A, this side was A, and here to here was A as well. Now I have 2 triangles, okay? Triangle A, B, D. Let me give them some color, right? Color makes things much more interesting to see. So, I have split this into 2 triangles. One is a blue triangle and one is a red triangle, and both are right angle triangles. Yeah. So ABD is my blue triangle. So this is my blue triangle. And second triangle is ACD. This is red one. ACD. Now I'm saying that both are congruent. The blue triangle and the red triangles are congruent. Can you guys believe it? Why? Yes, David.
So basically, since the first, like the top two lowercase a, since it's an equilateral triangle, and then if we get cut in half, those are both like obviously equal. And then the bottom a, we split it in half. As in like we bisected it.
Okay.
with the
Just give me 1 second, beta. 1 second. Okay. Yeah. Sorry. Go ahead.
So basically, the bottom one, we bisected it with a perpendicular line, which means that BD and AC are the same. So when we combine BD,
No. How did you derive it?
so it's the same.
How did you derive that these two are same?
Because I said that we derived it with so AD is a perpendicular line that bisects BC.
No. How did you get that? See, I have, let's say, I have a triangle like this. If I drop a perpendicular, it's not bisecting. Yep. Yep.
So you could use an SAS because the perpendicular is one side and the AB and AC are the same side, I think, because it's an equilateral triangle, and your angle 90 would be able to pull the proper angle, making the two congruent using SAS.
So let me see. These are 4 theorems. 3 sides matching, they are congruent. 2 angles and the side between them matching, congruent. 2 sides and the angle between them matching, congruent. This is for right angle triangle. Here you have right angle triangle, so don't even go any further. This says if your hypotenuse matches and one side matches, then they are congruent. Your hypotenuse anyway is matching because both are part of the equilateral triangle. And then this side is anyways common. So hypotenuse and one side are matching. These two are congruent. When they are congruent, then the third side will also match. So that is your point of it bisecting is right, but applying the theorem of congruence. Okay? So first I am trying to prove that these two are congruent using RHS, and if they are congruent, then this side will be equal to this side. Now the whole thing was A, so this became A by 2. This also became A by 2. Is that okay? I will give you 30 seconds to digest this. I'll be back. Okay. There's one problem. Small problem. Sorry. So again, going back to this one, that we took an equilateral triangle, dropped a perpendicular from here to this side, that split this into 2 right angle triangles, and I am saying that these 2 right angle triangles are congruent, because whenever we are dealing with right angle triangle, I will try using RHS because that's the easiest of the option. Okay, this is very specific to right angle triangle, and you see this side and this side are same because part of equilateral triangle. And this is common, so hypotenuse are same and one side is common in each way. So these two are congruent. When they are congruent, that means this side will be equal to this side, this angle will be equal to this angle also. So in case of equilateral triangle, all the angles are 60 degrees. Okay, so this is 60, this is 60, this was also 60, but now it is got split into 2 equal parts. This is 30 and this is also 30. Is that okay to believe? Chris joined little late. So Chris, what we are trying to do is trying to find out the value of sine, cos and tan for the commonly used angles.
I've been here.
Oh, okay. You were here. Okay. Alright. So I just need to log on to another laptop. Okay. There is an issue with this laptop. Let me join from here. Can you guys hear me okay here?
Yes, sir.
Okay, sir. All right. So this is better. So I will go to this laptop. Okay. Okay. So now this. Sorry kids, today we had some interruption for whatever logistics issues. So let me recollect myself. So Arush and Pranit, you guys are with me, right? Okay. All of you are with me, right? I know there's been a lot of disturbance because of me today, but who joined in between? I think it is okay. Sarah was not there. It was Neil. Or Neil. One of you were not there before. Both of you have joined now. Okay, fine. So okay, let me start from the beginning. Okay, I'm not convinced about how I have explained this to you guys. Okay? So and I'll go fast. I'll not waste a lot of time. We took an equilateral triangle. When we say equilateral triangle, that means this side are same. This angle is 60 degree, this angle is 60 degree, this angle is also 60 degree. So far, okay? Now, from here, we drop the perpendicular. So this was A, B, C. Let's say this length was X, this was X, and this was also X. When we draw the perpendicular from here to here, meaning this is 90 degree, and this is also 90 degree. And let's say this point was D. So we split this into two triangles, ABD and triangle ACD. So yeah, I'm not going to talk about it. I'm in the class. You guys figure it out. I did not do anything with the charger. Okay. So there is a blue triangle and there is a red triangle. So this ABD is the blue triangle. So we have two triangles, the blue triangle and the red triangle. This blue triangle and red triangle I am saying congruent because this is based on this theorem of congruence, RHS. When you have two right angle triangles, the hypotenuse match, this and this match, and then one of the side match. And this side is anyways common. So it's a common side for both the triangles. So these two triangles are congruent. And if they are congruent, that means this side and this side will be same. This angle here to here will be same as this angle. So that means this angle is 30 degree and this angle is also 30 degree. This whole side was x and x. This became x by 2 and this is x by 2. Up to this much okay? Are you guys convinced about whatever I have said so far, or you see a problem? Yes? Okay. Now take a copy of this triangle, okay? Look at this triangle. I am taking a copy of one of the right angle triangle, okay? So this is x by 2. This angle is 60 degree, this angle is 30 degree, and this is 90 degree. Okay? what is the length of this side? We have not figured it out. But then Pythagorean theorem says that this square plus this square will be equal to this square. So let's say this is k. So k square plus x by 2 square will be equal to x square. So k square plus x square by 4 will be equal to x square, or k square will be equal to, this thing goes that side, so x square minus x square by 4, which means k square equal to x square minus, so you take 4 as LCM, 4x square minus x square. So k square is equal to 3x square by 4. Yeah, that means k equals square root of 3 by 4 x square, which gives you k equals root 3 by 2x. This square plus this square equal to x square. K square, I am putting this as a k, so k square plus x square by 4 equal to x square. From this you found k square equal to 3x square by 4, 3x square by 4, or k equal to square root of this whole thing. So root 3 by 2x. So this is nothing but root 3 by 2x. And you guys can find by yourself also. I mean, when you try doing it, you will find the same value. Now I got this side, this side, this side, and I got angles also here. Now we'll apply the trigonometric ratios to find out the value of sine 60 degree and sine 30 degree. Is it making sense so far to everybody, or not really?
Yes, sir.
Ria, Neil, Sarah, Saranya,
Yeah.
Danvin, Ritika also okay?
Yeah, I understand.
Okay. So you guys see your teacher sweating big time. It's not because of the heat, it's because of the juggling I was doing in between. So here, now let's take this as an angle. Okay? Let's try finding out 60 degree values. So if I take this as an angle, sine 60 degree will be equal to side opposite to that divided by hypotenuse. So root 3 by 2 x divided by hypotenuse, which is x. So this is root 3 by 2 x into x. Tic-tac-toe, what you left with, root 3 by 2. Yeah? Same thing, cos of 60 degree. This is the angle, cos will be adjacent side divided by hypotenuse. So x by 2 divided by x. This gives you 1 by 2. Yeah? So this one is also proved. Now tan theta, tan of 60 degree will be this by this. So from that you can get root 3 by 2 divided by 1 by x by root 3 by 2x divided by x by 2 will give you a root 3. Either you find it that way or you do sin theta by cos theta, any which way is okay. Is it okay? Or am I going too fast? No? Okay. Now sin 60, sin 30 is tan 60, sin cos and tan 60 we found. Now same triangle you can use for 30 also, because you have one angle is 30 degree. So sine of 30 degree will be what? It's always, remember, now we have come to a point where every side in a triangle maps to an angle, okay? We will always relate that way. That is what we saw in the case of similarity, which was the root of deriving the Pythagorean theorem. So every side in a triangle that you see, you will always try relating it to which angle it is opposite to. So now sine 30 degree, if you are taking this as an angle theta, so sine 30 will be the side opposite to that divided by hypotenuse. So it will be x by 2 divided by hypotenuse. Or this becomes x by 2 into 1 by x. I mean, you know how the thing flips, right? So it becomes 1 by 2. Sin 30 is 1 by 2. Same way, cos 30, you will take this angle, This becomes your adjacent side divided by hypotenuse. Root 3 by 2x divided by x becomes cos 30 degree becomes root this is the angle, so this is opposite side, this is the adjacent side. So again remember this, when you are looking at your trigonometric ratios, whichever angle you pick, the side opposite to that becomes the way for finding sin theta by hypotenuse. If you are picking this as an angle, then sin 60 degree will be this side divided by hypotenuse. So remember this. There is nothing called this is not named as opposite side. This is a side opposite to this angle. So whichever angle you are choosing, you have to look at the side opposite to that. Okay. All okay? So we found that sin 30 is 1 by 2, cos 30 will be again, I am taking this angle, this becomes my adjacent side, so root 3 by 2x divided by hypotenuse, which is x. So this becomes root 3 by 2x times 1 by x. I am changing division to multiplication flips. So this x and this x gone, root 3 by 2. You saw this. Now tan theta will be what? Tan of 30 degree will be this side divided by this. So x by 2 divided by root 3 by 2x. It becomes 1 by root 3. Okay. So we have literally filled almost 4 columns of this table. Now anybody saying, okay, what is the value of sin 30 degree? You can remember it or you can prove it. Any which way is okay. Depending on how much time you have. And you will end up remembering it because you will deal with these commonly used angles so much so that this becomes a part of your basic calculation. Okay. Now let's go to 90 degree. Now look at this. This is let's say A, this is B and this is a C. This is a theta. When this theta becomes 90 degree, we are essentially talking about this becoming bigger and it goes here. So this hypotenuse became the height and this thing kept moving and literally coincided. So earlier in case of 0 degree your hypotenuse fell on this adjacent side. In case of 90 degree your hypotenuse will fall on the opposite side. So this base is becoming 0. This thing became 0. This thing became this here to here this distance became 0. When theta is 0 degree, your height became 0. When theta is 90 degree, your base became 0. Okay? So now if you try relating it to that, you will see that when you try relating to that, you will see that this side became 0. Now, here in case of this triangle, what is your sin 90 degree? Sin theta 90 degree, this height divided by hypotenuse. And here what happened is, it both coincided on this. So your height, this side's length and the hypotenuse length became the same. So if it was A, it also became A. So sin 90 is 1. Similarly, I mean, it had a little bit to do with the visualization actually. When this became 90 degree, your base became 0. And what is impacted? Your cos theta is the adjacent side by the hypotenuse. The adjacent side became 0. It's squeezed. See, when you are moving, when you are changing angle, see, this length is reduced. When you increase the angle further, this length is reduced. When you increase the angle further, see, this length is reducing. So by the time you make it 90, this became 0. This literally coincided. The height and this thing both coincided. The opposite side and the hypotenuse, they both coincided. So this length became 0. So cos of 0 degree will be equal to the adjacent side, which is 0, by hypotenuse, which is 0. Now sin by cos will help you determine tan of 0. So 1 by 0. Yep. I know I rushed through a lot of things while I was grappling with a lot of things in parallel. So, what is the takeaway from this? First thing, these are commonly used angles in case of trigonometric ratios, and we will deal with them very often. We learn how to derive those values so that we don't end up memorizing, okay, sin 30 is 1 by 2 and I have no clue how is that derived or arrived at. So now for sin 30 and cos 60 degree and 30 degree, you know that if you take an equilateral triangle and drop a perpendicular, you can make these two triangles congruent, and from that you can find out the length of these sides and take this and then apply the Pythagorean theorem. If you know this side and this side, you can find out this side, and then by applying the Pythagorean theorem, once you have it here, then you can derive the value for sin 30 and cos 30. Similarly, for sin and cos 45 degree, you took a right angle triangle which is also isosceles triangle, meaning this side and this side are same. So this angle and this both are 45 degree, and you apply the Pythagorean theorem to find out the length of the sides, and then use the trigonometric ratios to find out the value of sine, cos and tan 45 degree. Is that okay to believe or no? I mean, has everybody understood this? Riya, Ritika, Neil, Sarah, Dhanvin, Saranya, everybody? Okay. Now, the most fundamental question that you guys will have in your mind that, okay, learning is certainly important. We all need to learn. But why? I mean, if I have a right angle triangle where I know if I have this side, I can find out this side. Or if I have this side and this side, I can find out this side, applying the Pythagorean theorem. Correct? Why we have to learn trigonometric ratio? This is an extra burden. Yes.
We don't have the sides, we can only angles.
Correct.
We can use the sine function to the power -1.
Right. So see, what Pradeep is saying is, you have Pythagorean theorem which talks with respect to sides A, B and C. If you have two of them, you can find the third one, applying the Pythagorean theorem. Okay. So when you have this information about the sides, you can do that. Trigonometry helps you to find out the relationship between the side and angle. And now look at the situation. If I had this theta known to me, let's say 30 degree. Okay? And then I knew this side is 5 centimeter, and I didn't know anything else. Pythagorean theorem would not have helped here, but trigonometric ratio could. We know that, okay, sine 30 degree is the opposite side divided by hypotenuse. So opposite side divided by hypotenuse. And sine 30 degree, we know its value is 1 by 2. So 5 by x equal to 1 by 2. So x equals 2 times 5. That is 10. See, with one side and one angle, we could determine other side. And you can, same way you can determine this side and you can determine this side also. I mean, everything else. Yeah? So trigonometry actually expands the horizon for us where we can go beyond Pythagorean theorem and don't rely only on the information from side perspective. Ultimately, what we all need to do, if it's a triangle, the best we can find out is all the properties, sides, angles and the area and perimeter. That's it, nothing more. And how you can do it? After you have all the information. How you determine all that information is where the Pythagorean theorem or the trigonometric ratio help us. So Pythagorean theorem is more with respect to side. This is a combination of side and angle both, where you can relate your side and angles together. Yeah? Makes sense? Doesn't make sense? Teacher is boring. Okay. Now, let's look at one more thing. here. There's something called, okay, so yeah, as I was saying, so trigonometry helps you, relate angles and sides. Now there's another thing that you guys want to see. Look at it in an optical way for now. Look at this angle. Let's say this is 30 degree, this will be 60 degree, and this will be 90 degree. Now if you just look at this picture, you can see that this is the smallest of the three angles we have in this triangle, correct? Look at the side opposite to that. This looks to be the smallest among the three. If you look at, this is 60 degree, so this side is certainly bigger than this side. Since this angle is bigger than this angle, so you are seeing that this side, which is opposite to the smaller angle, is smaller than the side opposite to the bigger angle. Yeah? So there is a straight correlation between the angle and side, and that is what trigonometry establishes. See, this angle is 90 degree. The largest angle is 90 degree, and that is why your hypotenuse is always the largest side in a right angle triangle. Does it make sense, Ria, Davik? Yeah? Okay. Tansi? Okay, beta?
Yes, sir.
Okay. All right. So, let me see. Okay. All right. Vishal, convincing enough?
Yeah.
Okay. Now, so there are two things that trigonometry helps with. One thing is it helps us believe that angles and sides are correlated. You cannot have the side being the largest, which is opposite to the smallest angle. If it ever happens, let me know. Pick up any triangle for that matter, not only right angle triangle. Pick up any triangle. What you see is this is probably the largest of the three angles. You will find that this side is the largest of all. If this is the smallest angle, you can straight away see that the side opposite to that is smallest. So that is, it establishes the relationship between the side and the angle in the form of trigonometric ratios. And second thing is, obviously it helps you derive things when you are not constrained by only knowing the sides. If you know what are the angles, find out the sides. If you know all the sides, you can find out the angles also. Earlier that was not possible. Without trigonometric concept, that was not possible. Yeah? Now there is something called properties of complementary angles. What is complementary?
They add up to 90.
Add up to 90. You guys are too mathematical in nature. I'm a very normal human being. Complementary means when something complements, something that comes for free, something that adds up to make it complete, right? Something is complementing, right? I mean, you guys compliment me for me to be a relevant teacher, right? I compliment you guys to be relevant to you, right? So that is how it is. So complementary, like David said, if two angles A and B add up to 90 degree, they are called complementary angles. Yeah? If two angles add up to 90 degrees, they are called complementary angles. Now, let's see how does that apply in the case of trigonometry. Let's say this is theta. This is 90 degrees. Mandeep, you are 5 minutes early. You can probably join after 5-6 minutes, okay? Otherwise it will look a little too boring and tiring to you. If this is theta, Mandeep, join after 6 minutes. Okay. Ignore Mandeep. He is okay. He's done. So if this is theta, this angle will be 90 degree minus theta. Yep. So for this angle, this is the complementary angle. For this angle, this is the complementary angle because they both add up to 90 degree. Yeah? Saying something? Okay. Now, what the theorem of complementary or the concept of complementary angle says, sine of theta is equal to cos of 90 degree minus theta. Or vice versa. Cos of theta equal to sine of 90 degree minus theta. This is what the concept of complementary angle says. In trigonometry, sine of a theta is equal to cos of the complementary angle. Now you will say how? Let's look at it. Let's say this is A, this is B, and this is C. Sine of theta will be what? A by C. Sine of theta is this one. Now this is cos 90 of theta. Cos 90 of theta. Cos 90 of theta. So cos 90 of, this is the angle now. So sine, if I have to find out sine of this, it will be this side divided by hypotenuse. If I have to find out the cos of this, that means I have to take the adjacent side by hypotenuse. So cos of 90 degree minus theta will be equal to, this is the angle, adjacent side is this, opposite side is this. Adjacent side by hypotenuse. These two match. So this is also correct. Does it make sense? Now you say why is this important? If somebody gives you sine of 5 degree equal to, let's say, 0.31, find out the value of cos 95 degree. 85 degree. See, this is a complementary angle. 85. So sine of 5 is equal to cos of the complementary angle. So if you know sine of 5 degree equal to this, you will say okay, cos of this is also 3.1. So the table that we dealt with, right? Now you should relate it. Sine of 30 and cos of 60 will be the same. See? Sine of 45 and cos of 45 will also be the same. Sine of 90, sine of 0 and cos of 90 will be the same. Yeah? This is the concept around the complementary angle. And I sincerely apologize you guys for all the juggling I had to do in between. We started a little late, but I hope whatever we did in the class, that made some sense to you guys and we learned something out of it. Yeah? Any questions before I kind of let you guys go? No questions, Sanya? Okay. Neil, Sarah, Nikhil, Grace?
No, sir.
No? Ritika?
I don't have any questions, sir.
No question. Tansi already has given me a thumbs down saying, I don't want to talk to you. We are tired of you over the weekend and we have few more hours left in the weekend. So go and have as much fun as you can because fun of math is a complementary thing. If you are having enough fun, you'll have more fun with this as well. If you're not having enough fun, math will not sound like fun. Okay? Alright, with that being said, I'll let you guys go, enjoy the rest of the evening and talk to you guys. Talk to some of you on Wednesday and rest of you on Saturday and Sunday.
Thank you, sir.
Alright, bye bye. Bye bye. Take care. Bye bye. Bye bye.